Hi, and welcome to our first episode of Sci-News, where we explore various aspects of science, how it is present in our daily life, and how it resembles the world around us. Today, we'll be talking about noble gases and how their invisible characteristics are present in major parts of our political, social, medical, and economical issues. We'll use anecdotes and facts to present noble gases to you in a very easy way. I'm Ashley, and this is Savannah. When you think of a loner, what do you think about? I believe that loners are the perfect definition of a noble gas. If noble gases were a person, the first thing that would pop up on my mind would be loners, because they share similar characteristics.
Yeah, for me, I think of kings or queens who, even though are completely abundant in riches, they don't interact with the outside and, live solitary lives.
Yeah. Noble gases are known to be unreactive, which means their full 8-valence electron atom shell doesn't allow them to bond with anyone.
This sounds very similar to how loners act because loners have no real connections with people. What else is similar? Because they don't have connections with people, others tend to not notice them or even acknowledge their existence.
Noble gases, these inert gases on the far right of the periodic table, are odorless, colorless, non-toxic, and non-flammable, technically invisible, like loners. Because they don't have connections with people, others tend to not notice them or even acknowledge their existence. But even though there are clear similarities, I realize that there is a main difference between them that separates them completely. So now, our question is, are noble gases actually loners? Let's find out.
Helium, which is the first noble gas, is stored in an underground storage area managed by the U.S. government. This is because helium is used in many products to accomplish a specific function. Dr. Charles Grote, chair in energy and minerals resources and professor at the University of Texas, Austin, agrees and states the use of it in welding, the development of MRIs required helium, and then a lot of pretty important low-temperature physics research that was of strategic importance to the United States also. This shows that helium is very important in very many products. But why? The properties of helium, like their inability to bond and their neutral charge, causes them to have a very low boiling point and can become fragile in high-pressure environments. Actually, this is an advantage for products like balloons to make them float and car airbags to maintain pressure. Scuba divers as well have their tanks mix oxygen with helium to provide bubbles in the blood caused by pressure underwater. With that also being said, demand for more helium to produce and industrialize products increases. So because it is being used more often, it starts to become unobtainable.
It starts to become unattainable not because there is a lack of helium in the universe, but actually the underground storage area was running out. One thing that you need to know is that it's very difficult and expensive to extract helium from natural gas deposits. This is very alarming to the United States because if helium were to run out, the prices will skyrocket and then negatively affect the economy. So now, how is this problem going to be fixed?
Well, the answer to that is, for the meantime, using other noble gases. You might be wondering, why should we use other noble gases if the thing we need is helium? Well, actually, if we use other noble gases, they tend to behave similarly to each other and can cause them to react the same. This is because of their location on the periodic table that we can identify their periodic trends, which show similar properties to make them behave alike. These periodic trends include atomic radius, reactivity, ionization energy, and electronegativity. The atomic radius of an element is the distance from the nucleus to the outermost shell. In the periodic table, if an element is far to the right and in the upper area, it has a small atomic radius. In contrast to this, to the far left and down would mean that they have a large atomic radius. Since noble gases are all the way to the right, they have the smallest atomic radius out of all the elements.
This also means that noble gases have the highest electronegativity and ionization energy because the relationship between the atomic radius and electronegativity and ionization work in contrast to each other to prevent them from bonding. When the atomic radius of an element is low, the electronegativity and ionization energy will be high, and vice versa. This is directly connected to the reactivity of these gases. That is, if it takes a lot of energy to take away an electron, ionization, or attract an electronegativity, then they don't tend to make bonds at all. Therefore, we can classify them as unreactive, and we can all assume that by just looking at where they are located.
Argon and xenon are used to decrease brain injuries, scars, and dead brain cells because they are unreactive, making them block elements that increase brain trauma. Dr. Rita De Campos Pierre Santos E. Sosa, Clinic Research Training Fellow, for a study that examines how brain damage develops following a traumatic brain injury and investigates potential drug treatments such as xenon, a noble gas, and general anesthetic. We know xenon and argon can be used, but xenon is more effective than argon because argon covers less dead brain cells and injuries than xenon, due to the fact that xenon has a higher atomic radius. Dr. Robert Dickinson from the Department of Surgery and Cancer, who led the analysis, said, "They found that both gases significantly reduce lasting brain injury and death of brain cells, highlighting their potential for clinic treatment. But xenon was significantly more effective than argon, reducing brain cell injury by 27% versus 18% respectively. Helium as well is used in MRIs, a medical imaging procedure, to cool the magnets down and capture a good picture of the scanned body. That is partly because of its low boiling point that permits the current flow to run smoothly. Liquid helium has a notably low boiling point of negative 269 Celsius or around negative 452.2 Fahrenheit, so it's perfectly capable of cooling down MRI magnets. It is effective in bringing down the electrical resistance of these magnets to virtually non-existent levels, the next air article states.
This has nothing to do with medicine, but while you were saying that, I remembered a good joke about argon. It is so silly. Do you want to hear it?
Sure.
Okay, so where did the dinosaurs go?
I don't know.
Well, they are gone. You get it? Since argon is used to decrease brain scars, it, made the dinosaurs' population decrease as well.
Oh, I get it. That's a good one. Oh, that also reminds me.
Yeah?
Well, what if I told you that argon also helped disappear some people in Russia too?
What do you mean by that?
In the article Newsweek, I read that Ukraine is one of the biggest countries for noble gas extraction. This means that they extract xenon, number 54 on the periodic table, which is used for its sedative properties to treat anxiety and depression. With Ukraine being direct producer and Russia having access to this, it created conflict in the system.
What do you mean conflict? What conflict?
On July 22nd, 2021, a Russian technology entrepreneur was found dead in his office from an overdosing, stated by Newsweek. And a year later, it was found that one of Putin's top weapon designers died while undergoing xenon inhalation therapy. And since Ukraine is the exporter, who else is Russia going to blame? And that's where the conflict came from.
Oh my gosh, that totally sounds awful. I can't believe too much xenon could do that. I mean, I know we have talked about, the impact of helium, argon, and xenon in different areas like economics, politics, and medical procedures, but I haven't heard about neon. What does it do? Any significant functions that can completely blow your mind?
Yeah, well, it's not that impactful, but I do have this fact. Do you know those glow sticks?
Yeah, I do.
It is a lie that neon is using those. It is actually using TV screens to emit the light that we see.
What? You're joking.
No, I'm not. Argon is the one used for glow sticks. Neon is using TV screens. An article by Neon Creation explains, both sets of the electrodes span across the entire screen and are arranged in a horizontal and vertical columns to form a basic grid. In this grid, each tiny compartment contains a mixture of noble gases and a small amount of mercury, which forms a plasma when a high voltage is applied across the cell. The electrodes, which are basic conductors, sit behind cells along a glass plate. The plate is covered in a layer of protective magnesium oxide. The electrons create a grid pattern. When the electricity flows, the noble gases collide with mercury molecules that pass through the plasma. This collision is what creates the light we see on the screen.
Oh, okay, that sounds really cool. I didn't actually know that. And this collision and stuff, like, why does it collide with mercury?
Well, noble gases are nonpolar.
Can you tell me what that means?
It means they don't bond. That's why it collides. Noble gases are insanely unreactive, as we said before.
But wait, I'm confused. I think I read an article written by Bethany Halford telling us about how scientists have tried forcing bonds with the inert gases, and it actually did work. Chemist Neil Bartlett showed in 1962 when he made the first noble gas compound by mixing xenon with platinum hexafluoride.
I mean, yeah, they can bond, but at tremendously low temperatures. When they bond, they'll create covalent bonds, sharing electrons. But it doesn't take long for them to separate and break apart. If they warm above 27 kelvins, or if they touch one another, they readily break apart. Researchers at the University of Helsinki in Finland report.
That seems like an interesting topic to mention in another episode, but I think that's enough for today. Should we dig into the question we have tried to answer? Are noble gases actually loners? Savannah, do you want to answer it?
Sure. Well, we know that although loners resemble noble gases in a way, they don't share their most important trait, their presence. Loners are not as involved as the royal noble gases, and that's what throws away this perfect metaphor between them. The topics we shared: Russian xenon overdosing, the importance of helium in the economy, noble gases for medical treatments, neon in TV screens, element bonds and trends are clear evidence that noble gases contribute a lot and connect with the world more than we give them credit for. They are more complex than you think, more complex than kings and especially loners, affecting the world around us.
That's certainly true. That's the end of today's episode of Sci-News. I hope you enjoyed it and really learned something from it. Thanks for listening and stay connected for the next episode. Do plants have different flavors of sunlight? Releasing on the following Friday. We are Ashley
and Savannah.
Bye.